Coffee and Hawaiian shirt today. I'm ready to rock. I am ready here, people. Let's get into it. This video is the last video of this first unit. Now, you have a test coming up. It's going to include all the material on the videos that we have done so far and this last one on empirical formulas. Now, I've gone over empirical formulas before. Yes, I have. Yes, I have. And I talked about an empirical formula being the reduced ratio showing formula of the elements in a compound. I use glucose as an example. But for those of you who don't remember, you're all like, no, you didn't. Okay, well, I'll show you one more time. So glucose, C6H12O6, that's glucose or dextrose. You can reduce this down to CH2O. That is the reduced formula, and that's the empirical formula. This is the molecular formula. This is the empirical formula. All right, now the empirical formula, we're going to find out, becomes very important. We can do stuff with empirical formulas in chemistry. And this shows a ratio of 1 to 2 to 1 for the elements in that compound for glucose. All right, so that's an empirical formula. The reduced formula doesn't have any fractions. It's just a whole number ratio. All right, let's dive in. Let's do a problem showing how we can use empirical formula. Now, actually, what I did is I wrote this problem up here on the board, the one that's in the black marker, and then I was about to start it with the video, and I said, that one's going to be a little rough for a starter. So let's do an easier one to start with, and then I'll do that one for a second example. This one, so I wrote down quickly a problem here on the pink marker, red marker. It's going to be a little bit easier to do, but it's still done the same way. All right, and we'll show you why later on why this one is easier than this one. Okay, diving in. Now, over on this side, I wrote down some rules. Well, no, guidelines. You people don't like rules. You're rebellious. So you like guidelines? All right, here we go. So we've got guidelines of how to solve an empirical formula problem. And I will go through each one. I'll point each one out so it'll make more sense. Of course, I've abbreviated them to make room. All right, so here we go. Here's a problem. This problem says a compound contains 75%, and I change it to grams. That's actually our first step, is take your percents and change them to grams. All right, hang on, wait. Okay. 75% carbon and 25% hydrogen by mass. And its molecular weight, so this compound's molecular weight is 16 grams per mole. Find the empirical and molecular formulas for this compound. So we got to figure out what this compound is. That's what we're going to do. We're going to figure out what is it? What's the actual retail price without going over? No, that's Price is Right. Again, so the actual formula for it, that is the molecular formula. But before we do that, we're going to figure out the empirical formula of the compound. All right, now there are steps to do this. These steps are put down here. Let's go through them step by step and see what they mean. First step is, again, percent to grams. We're going to take the percent that you were given in the problem, and that is usually how it's done. You have a percentage of the mass. I need more coffee. The percentage of the mass, and it's given to you in that way as a percent, but what you're going to do is change the percent to grams. Just take the percent, cross it out, and make it grams. You can do that? Sure you can. You see, in this problem, we weren't given how much of the mass we have. We weren't given what the amount we have of this particular compound. We don't have that. Now, we have the molecular weight of the compound. That's 16 grams per mole, but that doesn't mean that we have 16 grams of it. We don't know. We don't know how much we have. We weren't given the amount that we have. So what we can do then is assume, and you can assume sometimes. Yes, you can. Yes, you can. We're going to assume 100 grams. If we had 100 grams of this compound and it's 75% carbon, then it would be 75 grams of carbon, right? Makes sense, because you know your percentages have to equal 100. So if it's 25%, all right, the hydrogen, then it would be 25 grams. It's that simple. Now, but you might not have 75 grams and 25 grams equaling 100 grams. You know, you might not. It doesn't make any difference. If we had 1,000 grams of it and 75% was carbon, it would be 750 grams of carbon. So we can take the percentages and just turn them into grams because they equal 100. So we can go ahead and do that. So that's the first step we do. And that's easy peasy. Just make those grams. Step 1, done. All right. Step 2, calculate the moles. Now what I mean by that is calculate the moles of the elements that are given in the compound. This compound has 2 elements, carbon and hydrogen. Now it could have more than that. It could be all kinds of them. It could have like carbon and hydrogen and oxygen, like it might be an alcohol or something like that. So we could have a lot of elements in it, but this compound has 2 elements. So let's figure out the moles, and that's what that means, calculate the moles of each one of the elements in the compound. All right, mole to mass conversion, what we did in the last video. Told you, it never ever goes away. You gotta know how to do it. Do it. Okay, carbon and hydrogen. So let's see, 75 grams of carbon, and we have 25 grams of hydrogen. Remember? Mole conversions, mass conversions, write down what you know you have. It's a factor label conversion. And put multiply, divide. Multiply, divide. So we're doing this for both. This is calculating moles. That means of both of the elements in the compound. Grams of carbon goes in the bottom. And this one, grams of hydrogen will go on the bottom. Okay, you know what to do now. You're at grams, remember? You're in Boston. And we're going to fly to Chicago. Yes, that's the mole. We have to go to the mole. So we're going to do a gram to mole. Mole carbon, mole hydrogen here on the top. Remember what's put next to the mole? Easy, right? 1. Put a 1 there. Go to your periodic table. Look up the masses of the compounds, or the elements in the compound. And carbon is 12. We're rounding that off to 12. Hydrogen is 1. Boom. We are now set up to solve for the moles of the elements in the compound. All right, so cancel. 75 divided by 12. So 75 divided by 12, 6.25. So 6.25, 6.25 moles. So that's 12 grams per mole, so 6.25 moles if I take that 12 and divide it into 75. Now this is going to be 25 divided by 1. Come on. 25 divided by 1, 25. Okay, so I have 25 moles of the hydrogen and 6.25 moles of carbon. All right, so I calculated the amount of moles of each element in the compound. Step 2, all done. Step 2. Step 3, divide each by the smallest moles. Now what I'm talking about is an abbreviation for this. I'm going to divide each of these moles that I just calculated by the smaller number of the moles. Now the smaller number, 25 or 6.25, is 6.25. So take each one and divide it by 6.25 because that's the smaller of the two numbers. Now you know 6.25 divided by itself equals 1. Okay? And 25 divided by 6.25, you can do that math, you can. It's 4. Right on the button, too. It's 4. With experimental data, things don't always turn out to be right on the button. I was like, right on the button, we done good. All right, so now what is that? Okay, so it tells me, it actually gives me a mole ratio. There's going to be 1 carbon and 4 hydrogens. So 4 hydrogens for every carbon. That's what it actually tells me. We're ready for the next step. Get whole numbers if needed. Now what that means is, we're going to see in the next problem, I am going to have to use that step 4. So I'll put a little asterisk here next to it, a little star. Sometimes you use it, sometimes you don't. And here's what I mean. I don't have to use it in this problem because I have whole numbers here. I have a 1 and a 4. Those are whole numbers. I don't have a fraction. If I had 1 and 2.5, all right, that's a ratio of 1 to 2.5, but you couldn't use 2.5 in a formula. You know that. You have to use whole numbers. So therefore, if I don't have whole numbers, I would use that step. We'll use that in the next problem. This problem, we have whole numbers. Step 4, not needed. Moving on. Find the empirical mass of the compound. Okay, find the empirical mass of the compound. Now what I've actually done at this point is I have already the empirical formula. You do, I do. We have the empirical formula right now. That's one of the two things we had to calculate. Calculate the empirical and molecular formulas. Boom, empirical formula, done, because we have the ratio, the simplest whole number ratio of the carbon and the hydrogen. It's 1 to 4. We've got it. Empirical formula is CH4. 1 carbon, 4 hydrogens. Empirical formula, solved. All right, now, we need to get the molecular formula because that's the other thing it was asking for. So the next step deals with getting the molecular formula. So actually I'll put a line here, a little dotted line, meaning that once we got through step 4, the empirical formula is complete. To get the molecular formula, we have to go on. So step 5, find the empirical mass. Okay, that means of the empirical formula. So what's the mass of this formula? If I were to go in and add these all up, remember, all this stuff is, it's all coming to fruition, isn't it? All that stuff we learned earlier, we got to put to use. So what's the mass of that formula? That's my empirical formula. Well, 1 carbon and 4 hydrogens. 4 times 1 is 4, and 1 times 12 is 12, so 12 and 4 is 16. So the mass of this is 16. Now I am running out of room here, so I'm going to get rid of this problem. Okay. And go ahead and solve the rest of it up here. So I know CH4 is my empirical formula. I know if I add this up, the mass is 16 grams. Okay, that's the mass of that empirical formula. All right, step 6. Now I didn't have room to write step 6. I was afraid you weren't going to be able to see it on the board. So I'm going to write step 6 here right now. Okay. Step 6 is take the empirical mass and divide it into the molecular mass. Now the molecular mass was given in the problem. I erased it, but I remember it. Okay, so what we do for step 6 is take molecular weight, molecular mass, remember we talked about that earlier, same thing. Molecular weight, and divide it by the empirical mass or the empirical weight. The empirical weight is 16. So take molecular weight and divide it. Well, I won't put take down there, it sounds weird. Take molecular weight divided by empirical weight, and you get a multiplier. This gives you get multiplier. Okay, so let's do step 6. Take the molecular weight, which was given in the problem, is 16 grams per mole. All right, so 16, and divide it by the empirical weight, which we just found to be 16 for this compound. So 16 divided by 16 is 1. And my multiplier is 1. What do you mean by a multiplier? What do you mean? What do you mean? What do you mean? I don't know where that came from. It all just came down from deep down inside. Sorry, or too much coffee. All right. Step 7, last step. Just follow steps, so people, this isn't difficult. Just follow steps. Multiply the empirical formula by the multiplier. So I'm going to write here empirical formula times multiplier. Okay, empirical formula times multiplier. This is my empirical formula, okay, CH4. Multiply it by the multiplier, which is 1. What is anything multiplied by 1? The thing you had. So the empirical formula is CH4, and in this problem, the molecular formula is also CH4. It didn't, but let's just say it did. But it didn't, but let's just say it did. The mass of this compound, if it came out to be 32, it would be 32 divided by 16, giving me a multiplier of 2. Then I would have multiplied CH4 by 2, giving me C2H8 as the molecular formula. Now that didn't happen. We'll see in the next problem, though, we will have to apply that. We won't get a multiplier of 1, but this time we did. And sometimes your empirical formulas and your molecular formulas, they are the same. And in this case, they were. All right, let's dive in to this next problem. Get rid of this problem. Okay. Is that gonna? It's gonna get in the way, isn't it? All right. I'm gonna take out here step 6 and step 7 and just refer you back to them in the problem, all right? If you don't remember what they are when I'm talking about them, just rewind. Okay, here we go. Percents, what do? Making grams. So your percentages, a compound is found to contain 83.7% carbon, so we'll make that grams, and 16.3% hydrogen, make that grams by mass. Its molecular weight is 86 grams per mole. What are its empirical molecular formulas? And let's go. Do it, get her done. So I have carbon and hydrogen again. There's another carbon. This is a hydrocarbon. So they're not all, every example is not going to be a hydrocarbon. I just happen to pick hydrocarbons. There's no hydrocarbon kind of a mood today. You know, I drove in, used some hydrocarbons in my gas tank. Yeah. Okay, so let's see. What do we got? 83.7. I need more room here. 83.7 grams of carbon and 16.3 grams of hydrogen. All right, do the math. The grams of carbon, moles of carbon. 1 goes next to the mole. 12 gets put down there for the grams. For the hydrogen, we have grams of hydrogen, 1 gram of hydrogen. Converting it to moles of hydrogen, which we always put a 1 next to the mole. All right, so do the math. It's going to be 83.7 divided by 12 and 16.3 divided by 1. So this will be 16.3 moles of hydrogen. Now that one I don't have memorized, so let's go ahead and do this one out. 83.7 divided by 12. Okay, 6.975. 6.975. What do you think that's supposed to be? Given there is always a little bit of experimental error. 6.975. 7. Okay, 7. 7 moles of carbon. All right. So step 1 done. Step 2 done. Step 3, divide each of the by the smaller number. Now the smaller number here is 7 out of the 2 mole calculations. Divide each one of those by 7. 7 divided by itself, of course, is 1. 16.3 divided by 7, interesting. That's going to be a little bit more than 2. Yeah, 2. What's going on here? 16.3 divided by 7 is 2.33. 2.33. 2.33. Or 2.333, repeating. 1/2 evil. 2.1/2 evil, yeah. Some of you remember. Yeah, you're good. Okay. Remember this 4th step that last time I didn't use? It says get whole numbers if needed. I don't have whole numbers here, do I? You have to have whole numbers in your empirical molecular formula. I don't have that. I'm already pumped to write my empirical formula for this compound with these ratios, but I can't. You can't say C1 H2.33. You know that's wrong. So you need to get this into a whole number. How? 0.33 is 1/3. It's the same thing. It's a fraction meaning 1/3. This is 2 and 1/3. How are you going to get 1/3 into a whole number? What would you do? If you wanted to get 1/3 into a whole number, what would you multiply by? That's right, 3. You would multiply by 3, and this would give you a nice whole number. So what we're going to have to do is multiply this by 3 to make it a whole number. But what you do to one thing, you got to do to the other to keep the ratio. The ratio is 1 to 2.33. Now we can't have the 0.33, but the ratio is still the same. So I'm going to multiply this one by 3 to get rid of that 1/3, and I'm going to multiply this one by 3 to get rid of the 1/3. So 3 times 1 is 3, and 2.33 times 3 is 7. Okay, that comes out to be 7. Those are my whole number ratio numbers I'm going to use in my empirical formula. So this empirical formula would be C3H7. That's my empirical formula. So if you're ever getting into a situation where you have something like you come out with 1/3 or 1/2, what would you do if you multiplied it by 1/2? What would you multiply it by to get rid of the 1/2? If you had this being 2.5, we would multiply this by 2, and we'd have to do the same thing to this one, multiply it by 2. So if it's not, but if it were 2.5, we'd multiply this by 2 and get 5, and this by 2 and get 2. We would have C2H5 as our empirical formula. Okay, that doesn't happen often, but it does happen, so we have to be aware of that. And you see, that's why this was not a good one to start out with. Once I put it on the board, I realized that. It's a little harder. All right, but we're almost done. Almost done. That's our empirical formula. Whoa! Get the empirical mass. Find the empirical mass of this empirical formula. That's our next step. Now I'm going to get rid of this to make some room. Okay, so let's get the mass of that. All right, we get 3 carbons. 3 carbons, 3 times 12 is 36, and 7 times 1 for hydrogen is 7. So that is 43. So the mass of that compound is 43. So we've got the mass of that compound, that's step 5. Step 6, remember step 6? We're going to take the molecular mass, which was given in the problem, and divide it by the empirical mass, which we just calculated. Boom, gives me a nice multiplier of 2. Comes out to be exactly 2. If it was 2.08 and you go, that's 2.1, we go, you know what, given the fact that errors are made in labs, and you always have some lab error, our brains would say, it's supposed to be 2, right? Yeah, we would say 2, yeah. They don't always come out to be exact, but in most of the problems I give you, they're going to be pretty darn close, if not exact. All right, so what do? Take that, step 7, and multiply your empirical formula. The empirical formula was C3H7. Multiply it by that multiplier, and that means I get C6H14. And if I remember my organic chemistry well, which I do, I love the organic chemistry, that would be a little hexane. Hexane, yep, driving in, get that in your gas tank, good stuff. All right, that wraps up the last thing. Now I'm going to give you a problem on your academic adventure coming up that will have an empirical molecular formula problem. Please have your steps written down. I mean, you can refer back to this video. That's going to take time. So have your steps written down, and if you follow the steps, piece of apple strudel.